In these problems, we're calculating the sample size needed to find a confidence interval. So let's take a look at 59. Here we have what sample size is needed to find a 95% confidence interval for the amount of eucalyptus leaves a koala will eat in a year if the standard deviation is 20 pounds and the margin of error should be 4 pounds. So since I know the standard deviation, then that means that this is a confidence interval about a mean. So we're going to use the formula n equals z sub alpha over 2 times sigma all over the margin of error quantity squared. So I'll start by finding z sub alpha over 2. And in this problem, we're finding the sample size for a 95% confidence interval. So in order to determine z sub alpha over 2, what I'm going to do off to the side is I'm going to sketch my normal distribution. I've got 95% of the values between these two z values. And so we're looking for this z value, the z value that cuts off the right tail. So the z value we name by finding the percentage in the tail, and since there's 95% in the middle, we've got 5% left over, and that means 2.5% in each tail. 2.5% in the right tail, 2.5% in the left tail. And so that means that we are calculating z sub 0.025. And I can do that with the calculator by just finding inverse norm of 1 minus 0.025 with a mean of 0 and a standard deviation of 1. And so this will turn out to be 1.96. So now I have my z value, and that's really the most complicated thing to find. All right, so now I can come back to my formula, and I've got 1.96 times sigma, which is 20, divided by the margin of error, which is 4. And I take that whole thing and square it. And when I put this into the calculator, I get 96.04, which means that we need a sample size of 97, since it has to be a whole number, and 96 isn't quite enough, so 97 would be the answer for this. So it's not a matter of rounding, it's a matter of going up to the next integer. So that's question 59. Let's take a look at question 60. In this problem, we're asked what sample size is needed to find a 98% confidence interval for the proportion of jaguars that are melanistic within a margin of error of 4% if a preliminary estimate is 6%. So in this case, we'll use another of the formulas from the front of the exam. Because there's a preliminary estimate for the proportion, we're going to use the formula n equals p times 1 minus p times the quantity z sub alpha over 2 over e, all raised to the second power, well, the z over e to the second power. All right, so p is our preliminary estimate, and in this case, that's 6%. So I'm going to put 6% for p, 1 minus 6% for 1 minus p. And then I need to calculate z sub alpha over 2 for this problem. And in this case, we are looking for a 98% confidence interval. So I'm going to do what I did for the last problem. Draw my normal distribution, and now I have 98% in the center. So that means I have 1% in both the left and right hand tails. So we're calculating z sub 0.01. And I do that by finding inverse norm of 1 minus 0.01, 0, 1, squeeze that in there, and this gives me 2.33. So now I can plug that into my formula. I've got 2.33 over, let's see, and the margin of error is 4%, so I put 0.04 in the denominator, and we square, and I get 191.36 something. And I don't really care how much the decimal portion is, because this tells me I need more than 191, so I need 192. And that's my final answer for this problem. Now let's take a look at problem 61. In this question, we want to know what sample size is needed to find a 90% confidence interval for the proportion of snow leopards that live above the tree line in summer within 5%. We're not given a preliminary estimate, so we're going to have to use a variation on the last formula that we used. And that's also given on the front of your exam. And this formula is 0.25 times the quantity z sub alpha over 2 over e, which is the margin of error, and we take the z over e quantity squared. So again, I'm going to figure out my z value first, and we are working with a 90% confidence interval here. So draw my distribution, 90% in the middle, which means 10% left over, and that's 5% in each tail. So the z value we're looking for is z sub 0.05. And we'll find that by doing inverse norm. 1 minus 0.05, 0, 1. And this will give me 1.64. All right, so we've got 0.25 times 1.64 over the margin of error, which is 5. And when we square that, and I've got 268.96, which means we need 267. And that is my final answer. And that's how you do those problems.